I've just kind of been following the homework because that's the best practice that, he tells us exactly where he wants us to focus on. I got a 4.1, and I can take a picture and send it. Mm, 4.1, 15, 27. Uh-oh.
No, I can do this stuff in my sleep, literally. So you're okay.
Okay. Okay, let me see. And then 51. Okay. Okay.
Oh, there we go.
Okay. And he had assigned 15 through 27 the odd, and 37 through 49 odd, and 57 to 59.
Repeat that to me again.
15 through 27 odd, 37 through 49 odd, and 57 through number 57 and 59.
Okay, the stuff that I'm looking at is like composite function stuff. Am I looking at the right thing?
Yes, composite functions. Yeah, that's yeah. That's, let me get my journal. Okay, so I need to log into Scrivener.
Yeah.
Okay, and plots. Will you be available tomorrow as well? I wanted to do more studying and then kind of go over stuff.
Um.
I don't know your schedule though.
When tomorrow?
I don't even know myself. It just depends on. I just want to go over stuff and then see what I probably have questions on.
Okay. Do you want to do it? Okay. Can you tell me tomorrow morning or tomorrow night? That's the thing.
Mm, tomorrow's Wednesday.
Yes.
Maybe tomorrow night. That'll probably be better.
Okay. Like this time. So after your girls are
Well,
bed.
I have class. Mm, let me see. Maybe do you have any availability in the afternoon, like before 4 p.m.?
Before 4, which would be 5 my time. I have an appointment from 2:30 to 3:30 in the afternoon. So that would be 1:30 to 2:30 your time.
Mm-hmm.
Um, I could see you after that.
Okay, that'll be good.
Okay. I guess just text me and then I'll See, if we're going to do an appointment, I want to make sure that I'm at a library because if my boys are here, I'm not going to be able to get anything done. Hold on one second.
Okay. I feel you on that.
Baby, they're going to go see Aunt Rachel tomorrow, right? In the afternoon.
Are you talking to me?
Yeah, I'm talking. Well, I'm not calling her baby.
I couldn't hear you over the dishwasher.
That would be crazy.
I couldn't hear you over the dishwasher.
I'm in Texas. I don't know what y'all talking about.
I ain't got nothing to do with it. What's happening?
You're going to see Rachel in the afternoon.
In the afternoon,
yeah. So you want like 4 or 5?
I'm going like 2:33.
Like 2:33. What time you coming back?
Probably not until 5.
Okay, the afternoon should be fine after I'm done with my appointment. If you want to work then.
Okay. What time would that be? My time?
That would be. I will be free at about 3:00 your time tomorrow.
Okay, that's cool. So like 3 to 5.
That's right. So if you want me to set it up, just text me in the morning if you end up getting free.
Okay. Because you could do earlier. Is that what you're saying?
I could do. I mean, the only time that I don't have, I could either do sometime between 10 and 12 your time, or sometime after 3 your time.
Okay. Okay, cool. I'll text you. See how the day goes tomorrow.
Okay. All right. So, which question would you like me to do? Like, where does the confusion come?
Okay.
Can you do the ones 15 through 23? Can you do those questions that are like that?
I'm gonna be honest with you. It looks like Chinese.
Okay. Okay. All right. Let me do.
It doesn't look like when it was in chemistry. It was so direct, the log and everything when we were doing it in chemistry.
I don't see any logarithms here on this page that you send me. There's logs on here?
Well, this section's about logarithms as well, but this is just one of the sections.
Okay.
Yeah, this is just 4.1.
Okay. Well, I'm gonna do number 19 for you.
Okay.
Okay. And I'm gonna write A, and that's F of G of 4, and then B is G of F of 2, and C is F of 1, and D is G of 0. Okay, so I'm going to start with 19.
Okay.
I'm trying to do one of the harder ones so you can see how it works.
Okay. I just logged in. Okay, I can see what you're doing. Okay. So 19. F of x equals 3 over x plus 1. G of x equals 3 cubed x. And so they're asking to do the f times g for. So are you plugging the 4 into the x?
Okay, so yeah, but watch what I do. Okay.
Okay.
When you're doing f of g of x, you do the second one first, and then you plug that answer into the first one.
Okay.
So this is what I'm going to do. I'm going to try to write it in different pieces. So the first thing that I'm going to do is I'm going to do g of 4. So g of 4 would be the cube root of 4. Okay?
Okay.
Now I'm going to take this answer. Hold on one second. I want to get rid of that line.
So what you were saying is that you have to do what's in the parentheses first. The G of X. You have to solve for that
Whatever the
first.
second one listed, you do that part first.
Okay.
And then you take that part and you plug it in to the X in the second part. Did you see what I
Okay.
just did there?
Yes. So the cube of 4, and I always just do 4 to the 1/4 power. Oh, 1/4 power to solve it.
The
Oh,
fourth,
1/3 actually.
yeah. So you can write it this way.
Yeah.
And then I'm
Oh,
going to say f of g is equal to 3 over 4 to the third plus 1.
okay.
And that would be your answer.
So you go ahead and plug it in.
Then you stick it in the calculator to actually find the answer. Does your teacher want you to do that, or is that good enough, just knowing that you know how to plug it in, or do they want an actual number?
Let me see what the answer is. He likes things simplified. I think 19. Let me see. 4.3.
Okay, so I'm going to do B now. So I'm going to stick my 2 into F first. So what is F of 2? That would be 3 over 2 plus 1, which is equal to 1.
Yeah, he has 3. The cube. Well, the answer in the back of the book it says 3, and the cube of 4 plus 1. So it just keeps it that it doesn't simplify it
Right.
anymore.
And most math teachers don't simplify that stuff. They just leave it like that.
Okay.
Okay, so do you see how I got F of 2?
Well, f of 2. Let me see. Because you said you had to do f of 2 first, because that's the second one, right?
Right.
Okay. And so you just plug it in. The absolute value of 2 is 2.
Where did you get the absolute value from?
Oh no, I'm looking at 17. Okay, now we're on 19. You gotta plug it in. So 3, 2 plus 1, 3 over 3, 1. So f of x is equal to 1.
Right.
And so that's what you would plug into the g of x.
Uh-huh. So
The
G of F of 1 would be the cube root of 1.
1, which will be 1. So that would be your answer.
That would be your answer.
Okay. So you just kind of have to know the order that you're doing it in.
It's always the second one first.
Do the second one first. So solve for the second and plug in.
And then plug the answer into the first. You still mashed potatoes in there? I can't. Yes,
Okay. Cool.
what'd you end up getting from the store?
Put the domain of the composite effort. Okay. Now this one says find the domain of the composite function f of g, 41 through
Did you just smell
Okay.
it?
Um,
27.
okay.
Just
The thing that you have to know is that the domain of the second function has to be defined in order for the first function to actually work. So let me do number 21 so you can see what I'm doing.
okay.
So f of x is equal to 3 over x minus 1. And then g of x, no, 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 no. Because you need to go upstairs and go to bed. Okay, so the first thing that I have to do is define the domain for this function. If I'm going to do f of g of x. Do you know how to determine what the domain for that function is?
Well, you have to graph it, right?
Nope. I'm gonna give you 3 different cases where the domain isn't all real numbers.
Okay.
Whenever you have a variable on the bottom, whatever is on the bottom here, doesn't matter what the equation is, you say that that can't be equal to 0.
Right. Mm-hmm.
So if I had 1 over x plus 2, then I'm going to take the bottom and set it equal to 0. So x cannot be equal to negative 2. So it's all real numbers except for negative 2. That's the domain. That's one of the cases. The other case is when I have something underneath a square root. What kind of numbers can't you have underneath a square root?
Negative numbers.
So that means that whatever's in here, I have to say is greater than or equal to 0. So for example, if I have x minus 4 is underneath the square root, then I'm going to write this inequality. X minus 4 is greater than or equal to 0. So x has to be bigger or equal to 4. So it's that would be your domain.
So that would be your domain.
Mm-hmm.
X, whatever you're solving for X would be your domain.
Right. Whatever x is equal to, that's your domain.
Okay.
The third case is a mix of the two. So that means that I have some number and I have a square root in the denominator. So whatever's underneath here, I have to say is greater than 0. Because the number underneath can't be equal to 0, right?
Right.
So if I had x squared plus 4x plus 3 over the square root of x minus 5, the top doesn't matter. The only thing that's
Mm-hmm.
important is the bottom. And so I'm going to take the bottom and I'm going to say x minus 5 is greater than 0. So x has to be bigger than 5. So that would be my domain.
Gotcha.
If it's not one of those 3 cases, then it's all real numbers.
Okay. So if it is any of these cases, then it's not real numbers.
Then it's all real numbers. That means the domain can be anything. Those are the only 3 cases where you don't have all real numbers. So it's either something on the bottom of a fraction, something under a square root, or something under the square root in a fraction. If it's not one of those 3 things, then it's all real numbers. So which case do I have here?
Oh, the one we're trying to solve?
I'm trying to find the domain of it. Which one of these three cases do I have here?
The two events. You have the one where the denominator cannot equal zero, so you have to have it greater than zero.
Nope, it's all numbers except for 0. It's that one.
Okay, it just can't equal zero,
It
so
just
it's
can't
this
equal
one.
0.
Okay.
So that's the first part of my
If it was
domain.
greater than zero, then that would include the square root. Okay.
Right. All right. So now let me erase some of this because there's a lot of stuff here.
Case one. Case two. So the actual domain would actually be what it cannot be, right? If it was any of those cases.
It would be all numbers except for. That's why you write the equal sign with a line through it because it says it's not equal to that. So it's all numbers
Okay.
except for that. This means except.
Okay.
Okay, so now the second thing that I'm going to do. Oops, I went one too many. Oh, Lord Jesus. Okay. So remember, the domain for g of x is x cannot be equal to 0. That's for that one.
Okay.
So if I'm doing f of g of x, then I'm going to take this thing and plug it in to x there. So you get 3 over 2 over x minus 1. Do you see how I got that?
Okay. You plug the g of x inside of the f of x. Okay.
Right. And now I'm going to try to figure out the domain for this. So
Okay.
I'm going to write this like this. 3 divided by 2 over x minus 1. I'm going to write them side by side. Now I'm going to simplify this thing.
Okay.
So this would be 2 minus x over x. Do you see how I got that?
You flipped it to multiply?
I didn't flip it.
Oh.
So let me show you the long way of doing this. Okay, this is 1, right? I can write 1 as x over x, right? Isn't that equal to 1?
That's true. Yeah.
So then this would be minus 2 over x. The denominators are the same here, so I only have to write it once. And so this would be 2 minus x on the top. Which is what I got here.
Okay. Got you. Okay.
Okay, so, and if you need help with like simplifying fractions, there is a quick way or a pattern to do this each and every time, and that's what I use. I literally take this bottom number and multiply it up, and then multiply straight across, because that's 1 over 1. So if I take x times -1, what do I get?
-1.
X times -1.
-1x.
That's where this comes from. And then now I have a common denominator, because what is x times 1?
1x.
1x. That's where this number comes from. So then when you subtract them, you get this fraction. And maybe we should practice that, because everybody should know how to do that. It makes doing fractions easy. So now I have this all together. And when I'm dividing by a fraction, I have to flip the fraction and multiply. So this is equal to 3 times x over 2 minus x.
Okay.
And now I have a new thing that I can find the domain of. What do I have to set the bottom of that equal to or not equal to?
1 of 3?
No.
Are you talking about 3?
No, not the 3. When you're doing domain, the only thing that matters is the fraction. Do you see the thing that I have circled?
Okay. So you don't want it to equal 0. So you don't want x to be 0. So
Right.
x can't equal 2.
So x is not equal to 2. So those are both parts of your domain, those two things that I have circled. X cannot be equal to 0, and it cannot be equal to 2. So it's all real numbers except for those two numbers. Now, do you have to write that in interval notation, or can you just leave it like that?
Let me see how they solve that question. 21. They have x cannot equal 0, and they have x cannot equal 2. That's just what they put.
Okay. Well, then I'm not going to go over interval notation because we don't have enough time to do that. That's just something extra that you don't need to know right now.
And I think based on class, I think he's okay with that. He's just big on simplifying. If you get to the answer, he's not really big on, the interval notation and stuff.
Okay.
Unless it's specifically asking for that, yeah.
The most important thing that I want you to remember is that if you're doing a composite function, whatever is second is part of the domain. So that's the first thing that you have to find.
Okay.
Then you substitute that part of the function in. That's how I got this. And then you find the new domain by simplifying it. And both things, this thing and that thing, are now part of the domain for the composite function. So always find the domain of the second function first, substitute it in, and then simplify to find the new domain. So I think you should probably go through and do one yourself with me helping.
Okay.
Yes?
But absolutely. Are you laughing at me?
Yes.
23. Well, we've done one like that, so let me do one with a square root, right?
Yep.
Let me do 27.
Yep.
Okay, so 27, the f of x equals x squared plus 1, and the g of x equals the square root of x minus 1. Okay, so first of all, you have to do the second one first. So we know that in a square root, you can't have it be negative. And so you're gonna Um, equal to zero. Okay. So you're basically saying that it can't equal -1.
No. Whenever you have a square root, you take what's inside the square root, so that's x minus 1, and you say that that's greater than or equal to 0, and then solve that inequality.
Okay, +1. So x equals 1, and so that's 0. That's actually okay.
Right. That's actually okay. So this is the domain for that function. X is greater than or equal to 1.
So it looks like you have to, once you have that function, you have to solve for 0, right? What the x-intercept is, the 0 of the function. And
You
then
make you
based
make
on
it
what,
you're making it way more complicated than you have to. You're making it
okay,
way more complicated than you have to. I'm not asking you to graph it. I'm just asking you to find the domain. So in order to find the domain, you just take whatever's inside of that thing and you make it and you set it greater than or equal to 0 and solve. So this is
okay,
your domain.
okay. So the reason why we're able to equal it to 0 is because it can be 0. That's fine.
Right, because you can have the square root of 0. What's the square root of 0?
0. Mhm.
So that gives you a number.
Okay, gotcha. Okay, so so that's our domain for that one, and then you go ahead and plug it into x squared plus 1.
Yeah.
1 squared plus 1, so it's 1 plus 1 is 2. So f of g of x equals 2.
There's something not right with that.
Do you
Okay.
have to set it equal to 0?
No. Okay, so if I'm going to substitute this in, this is what it looks like. It's going to be the square root of x plus 1 squared plus 1. Is that what you have?
Or 27? Okay, that's what I know. I don't have that.
I'm sorry, this should be minus 1. This has to be minus 1, sorry.
Okay, so we got to substitute it in first.
Yeah.
Okay,
And
so
you substitute the whole function in, not just the stuff that you got to substitute the square root in itself too.
okay,
You see what I did there?
okay. Square root of x minus 1 to the second power plus 1. Okay.
Do you understand how I got that?
Yeah, you substituted g of x into the x
Right.
in f of x function. And we already know what our domain is. So do we set that equal to 0 now?
Nope, simplify it. Remember, we have to simplify that now.
Okay. Well, we solved it for, I mean, do we have to do the square root of 0? What we had for our answer before?
Um, I need you to solve that for me. You shouldn't get the square root of 0 at all. Can you simplify this? Do you know how to?
I don't think so. No.
Okay,
I,
you have a square out here, right?
mm-hmm.
And you have a square root there. What happens to those two things? What happens when you square a square root? What if I had this?
Oh, you get rid of it.
They cancel each other out, right?
Yeah.
So this cancels that. So then you're left with what?
X minus 1.
What about this part? Isn't there
Plus
still a
1.
plus 1 there?
Plus 1, yeah.
Okay.
And then then that cancels out minus 1 plus 1. So you're left with x.
And that's it. Okay, so I'm going to say this to you out loud. Whenever you stick one function inside of another and your answer is x, then those two functions are inverses of one another.
Okay.
Have you guys talked about inverse functions yet? It looks like this.
That sounds familiar. We're probably on our way there.
Okay. Okay, so what's
So
the so my
whenever
question
you put a function inside another function and the answer is x, they're inverses of each other.
right. So g of x is the inverse of f of x. You might be getting to that eventually. Maybe you don't need to know that yet.
That does look familiar. It does. So g of s is the inverse of f of x. Okay.
Okay, so my question to you is, what is the domain for this?
X and 0.
Is there any number that x can't be? If I just said that f of x was equal to x, is there any number that I can't stick in there for x?
X could be anything.
Right, so this is all reals. Right? Because it can be anything, right?
Yeah.
So then we have to go back to our default. So we have to go back to this. So this is going to define my whole domain.
X greater or equal to 1.
That's the domain for g of f of x.
How did you find that?
Remember, the second function has to be defined in order for the composite function to be defined.
Okay.
So wasn't this the first domain that we found?
I thought we found that it was just 0. What I thought what we had was x minus 1, square root of x minus 1, and then we found out we set it to 0, and then x equals 1. What did I do?
Okay, I'm gonna simplify this because I don't think that you're getting it. So we're gonna do this a bunch of times until I know that you get it. Because doing composite functions, if you don't understand how to find the domain, is just going to make it more complicated. We're like skipping steps. So I'm gonna give you a bunch of practice.
Okay.
Tell me the domain for that function. Tell me what you do.
Okay, g of x equals square root of 2 of x plus 5. Well, you set the 2 of x plus 5 to 0 and solve.
I want you to write it down so I know that you're saying what I think you're saying. Because if you do what you're saying, if you do what you said, it will be wrong. So I want you to write it.
Okay, I'm ready. Okay. Equals 0 because it's okay for square root to equal.
I'm going to change this because that's not right. Okay.
Okay.
It actually has to be this specifically. You have to solve that.
Okay, it can be greater or equal to 0.
Right.
Okay, that's fine. That's true. I don't know why I just focused on the 0 part. Okay, I think that's what I missed in the other problem. Okay, so minus 5, minus 5.
Mm-hmm.
So 2x to negative 5 divided by 2. So x equals. Do you change your sign?
Only when you
Because
divide by a negative. So if you're not dividing by a negative, you don't flip it.
okay, and then the absolute value you do that though, right?
Yeah. Yes, when you're doing the negative case. Yeah. But this is not the same thing, so I don't want to confuse it.
Okay. So x is greater than or equal to -5/2.
Right. So do this one.
So this is your domain.
That is your domain.
And so like if we had an f of x, we would stick we would stick this whole thing in, right? Isn't that what we did? Like if we had an f of x.
You stick the whole thing in, including the square root, into the next function. You stick all of it.
And then solve?
And then solve. But this is always going to be part of your domain. The first thing that you solve will always be part of your domain. That will never change. Okay, so I want you to do this one. Find the domain for that one.
Okay. Okay. So what x can be? Okay. +3. Okay. See, for this one, you have -2x + 3, right?
Uh-huh.
And so I know that it can't be negative inside of there, right?
You're thinking too hard. Just do the
Should I
exact
just
same thing each and every time. You're trying to make it harder than it is. Do the exact same thing each and every time.
Okay.
The number will come out once you do the math.
You switch your sign because you're dividing by negative.
Right.
Over -2. So this is positive 3/2. X is less than or equal to 3/2. That's bad.
Right. You don't have to fix it. You don't have to fix it. I'm trying to get through as many of these as possible before I go to sleep. Okay? It doesn't have to be perfect. I just want to make sure that you understand it.
Got you.
Okay? So here's the next one. Let's say
Okay. So you'll do the same thing each and every time. 2x - 4 is greater or equal to 0 because you don't want it to be negative. So +4. So you got 4 on this side. And then it's going to be 2x 4 divided by 2 is 2. X is greater than or equal to 2.
Good.
Mm.
Do you
And so
get?
that's your domain.
So that's your domain. Do you get that now?
Yeah.
Because I'm about to switch it up. Okay. Here's the
Okay.
next case.
But like when you're putting it in, how do you know? Like when you're putting in, you that's like okay. That's what you're doing now. Okay.
Mm-hmm.
Okay.
We'll get to the putting it in part later. I want to make sure you understand all three cases first. We
Okay.
got to do one step at a time. Because if you don't get these three things, then you won't get the second part right. So we
Okay.
got to do this part first.
Okay. So you know it can't equal 0. This whole thing can't equal 0. So how did we do the half before? Let me see. Okay. So you set it equal to 0 to find out what it is,
Mm-hmm.
because you know it can't equal 0. So we just kind of solve.
Mm-hmm.
Divided by 2. So x cannot equal 2.
Good.
So that's your domain.
So that's your domain. It's all real numbers except for 2.
All real numbers except for 2. Okay. Okay. The same thing. It can't be 0 at the bottom.
Mm-hmm.
And then you solve for 0 to find out what it is. Divided by 2. You're going to be left with -3.
Mm-hmm.
So x cannot equal -3.
Good.
That'll be your domain. All real numbers except for -3.
Good. Okay.
Okay. Okay. So for this one, you have a square root. So it can't equal 0 and it can't be negative. So you want it to be greater than 0. Because it can't equal 0. So we wouldn't put it the equal sign. So you just want it to be greater than 0.
Good.
Then you solve to find out what it is. Plus 4 divided by 2. X equals 2.
Change it. What's your mistake?
Plus 4 plus 4. 4 divided by 2 is 2.
Your
X
math is
equals
right,
2.
but your symbol's wrong. Your math is right, but your symbol is wrong.
Oh. X is greater than 2.
There you go.
Okay, so it's all X is greater than 2. So your domain is everything
Bigger than 2.
bigger than 2. Okay. So all real numbers greater than 2.
Mm-hmm.
Okay. Okay. Same thing. You can't have the denominator equals 0. So you want it greater than 0. And if it's greater than 0, it's not going to be a negative in the square root. So plus 6 divided by 2 is going to give you 3. So x is greater than 3.
Do you see the 3 different cases now?
Yes, I do. Because here it can't equal 0, so you find out what it can't be. So it's all real numbers except for 2.
Right.
Here it can't equal 0 because it's at the bottom, so it's all real numbers except for negative 3. Here it's a square root. It can't be negative, and it can't be 0, so it has to be greater than 0, which fills both of those requirements.
Right.
And so it's all real numbers that are greater than 2, and the same thing goes for the bottom as well.
Okay. So we're straight on that now, right?
Yeah.
Now we're going to go back to actually substituting. Remember, if this is the function that I'm sticking inside of another function, I have to keep that domain no matter what happens. Okay?
Okay.
So let me give you a simple one to do that you have to substitute in. I'm going to say f of x is equal to 2x. And I'm going to say g of x is equal to 1 over x plus 4.
Okay.
And I want to know the domain of g of f of x. And then I want you to find the domain of f of g of x. So I want
What
you
does
to
that dot mean with the dot? What does that mean? Does it this one? Yeah.
Here's another way of looking at it. It's like saying, here's my g function, and I'm going
Mm-hmm.
to stick my f of x function inside.
Okay. It's just another way of notating that.
Right. It's another way of notating a composite function.
Okay.
So that little circle thing means composite. So you're literally taking the first function and sticking it inside of the other function.
Okay.
So what is the domain of this? Because that's what we have to find out first, because that's the second one, right?
Mm-hmm.
What's the domain for that function?
Well, it can be all real numbers.
Okay, so that's the domain, right? So now the second part is I have to stick that into g of x. So what does that look like?
Okay. Plus 4. Okay.
And now it's like a completely new question. You're going to solve the domain for that.
Well, it can't equal 0. That's what we know. But it's gonna be -4 divided by 2. So -2. I need to make sure I put this here. So the domain cannot equal -2.
Right.
So it's all real numbers except for -2.
Correct. Now I want to go the other direction. So do this one for me. So what do I have to find first?
You have to find the second function first. Find the domain of the second function and then plug in the whole function into the first function and find the domain of that.
Okay.
So if they're asking what is the domain of this g of f of x, it's both of those, right? You have to include that what f of x was, so it's going to be all real numbers except for -2, right? Because you're including them.
No, it's a completely different question. So this one is my second one, right?
Mm-hmm.
So I have to find the domain of this first. What's the domain of that?
The domain of this can't be 0, so it's -4.
So tell me what the domain is. Or write it down so I see it.
X cannot equal X is not equal to -4, so all real numbers except for -4.
Okay, so I have to keep this domain, right?
Yes.
What's the second step? What do I do now?
Is this a whole new problem?
Yes, it's a whole new problem.
Oh, okay.
This is not the same as this. It's
Oh,
completely different. Look at the domain. You got x is not equal to -4 in this case, and in the other case you got x is not equal to -2. Are those two the same domains?
no, they're not.
It's a completely different question when they ask it to you.
Hmm.
That's why you have to follow the steps each and every time.
Okay.
Because of
So
go ahead.
trying to go through all the steps. So G of f of x. So we start with the second one, and we find out what's the domain of the second one, because that's the first thing you need to do.
Uh-huh.
We found out that it could be all real numbers, right? And so we put it into the G of f of x, right, or
Uh-huh.
whatever you want to call it, and we found out what the domain is with the f of x inserted in there.
Right.
And you solve the g of x by itself, right?
Right.
You have to do. It's like you have to do 3 steps. Mm. Am I wrong or am I right?
Um
It's like you're doing 3. It's like you're finding the domain of 3 different things.
you're only
That's what it
finding the
looks.
domain of 2 different things.
Mm-hmm.
This question is like question A. This question is like question B, and maybe that's why I'm confusing you, and I'm not meaning to. This is a
Okay.
completely separate question. We finished this question when we did this part.
Oh, okay. Got you.
Now I'm asking you a completely different question, and I want to show you that the domain is going to change depending on which function goes inside. That's what I'm trying to show you. So I'm asking
Okay.
you a completely different question. When you got this answer down here,
Hmm.
you already answered the first question. Now I'm asking you a completely different question using the same 2 functions.
Okay.
So I want you to finish part B because I want you to finish it. You haven't finished it yet.
Oh, okay. Okay, I see what you mean. So this is a whole new question. So that we're doing the second one first, and we're finding out what the domain is of that, and we did. Now we need to go ahead and plug that into the f of x.
Yes, yes,
Okay.
yes.
And that I got confused with, like, what if it was a new question or if it was the same. Okay. So 2 times 1x plus 4. Okay. Now, automatically, I kind of want to do something like this just so I can look at it better.
Okay.
X plus 4. Okay. And then just distribute top bottom 2 over x plus 4. And you can simplify this. So wouldn't it be
Can you simplify that?
no?
Mm-mm. You've done enough. Okay, so how do you figure out the domain of that?
Okay. You know it can't be 0.
Mm-hmm.
So, but if it was the opposite, you could simplify it, right? Okay.
You mean if the x plus 4 was on the top
Yeah.
and you had just a 2 on the bottom, you could separate it. Yes, you could. You could separate it.
Minus 4, minus 4. So x cannot equal -4. So that is our domain.
That is your domain.
So these two. So if they ask a question, that's the same thing. Uh-huh.
That's because I made it easy because I wasn't trying to make it complicated. I wanted you to. The thing that I wanted you to see is that that domain and that domain are not the same. That's what I wanted you to see.
Okay.
So the g of f of x and the domain for the f of g of x are two totally different domains, even though you have the exact same two functions. That's what I wanted you to see. Do you see that?
Yes. So they're not inverses of each other.
They're not inverses of each other.
Okay. Got it.
Let's see what else you have on here. Oh, questions 47 through 54 are basically doing the exact same thing we just did.
Okay.
Is that part of your homework? Because that's showing the inverse.
Let me see. Let's see what this. Well, let's see. Here's chapter 4. 57 and 59. And then it had 37 and 41.
You said 57 through 59? 57?
Just question 57 and 59.
Okay, I can do those quickly.
Okay. And I can, and based off everything we learned, I can do the other ones, right?
Yeah, you should be able to do the other ones because it's just doing the exact same thing over and over again.
Yeah, but it's just saying X instead of a number. They gave us a number last time, right?
What'd you say? I'm sorry.
They gave us a number, like for the composite function, they gave us like a number 4, but here they gave us X. So you just kind of replace it.
Yeah, it's just like I just did because remember the last set of stuff that we just did, I didn't give you a number to put in there. I just told you to stick in the function and then simplify it, right? Okay. When you are doing, they're saying that h of x is f of g of x. So this h of x is a composite function.
Mm-hmm.
So this is how you separate it. I'm going to look at the thing that's inside the very most. So g of x is equal to x squared plus 1. It's that part.
Okay.
Do you see how that's inside the square root? And do you see how I left the square root out of the g of x? Do you see that?
I think I need to write down the problem. Find the functions f and g so that f of g equals h. F of g equals h. And then, okay, so 57, they said h of x equals the square root of x squared plus 1. And you said g of x equals x squared plus 1. Okay, gotcha. Okay.
So I literally took that g of x.
Mm-hmm. And made x squared plus 1 the g of x.
So I literally stuck it inside that square root, right? And now I'm just taking it out. Do you see how I'm just taking that out?
Right.
Okay. So what's left behind?
The square root.
So look at what I'm going to do. I just replace what I take out with an x.
Replace what you take out with an X.
So if I take the g of x part out, and I'm going to highlight it. I won't let me do it. Hold on one second. I'm just going to rewrite it. You see what I have written there, right?
Mm-hmm.
Oh my goodness gracious, what's going on here? Let me just start all over. Hold on. It's doing a weird thing. Okay, so that's what I'm starting off with. I'm going to take the most inside part out.
Okay.
Uh,
And you made it the G of X?
and I
Okay.
made that the g of x. I don't know why it won't let me. It wants to take all of it. Okay, this is just getting on my nerves. How about I do this? So I'm going to take that part out. So that's the part that's on the inside, right?
Right.
And I'm going to label that as my g of x.
Okay.
I'm going to call this my f of x.
Okay.
But in order to be an f of x, I still have to have an x in it. So I'm just going to put an x inside.
Okay. Gotcha.
So if I'm doing f of g of x, then this thing here gets substituted into there, right?
Mm-hmm.
And isn't that my original function to begin with?
It is.
So you always take the most inside part first. That's going to be your g of x. And then the outside part, you just put an x inside. So if I have h of x is equal to the absolute value of 2x minus 5, and I'm saying that that is equal to f of g of x. What is the
Mm-hmm.
inside part of that?
It's gonna be 2x minus 5.
So that's going to be, is that my g or is that my f?
That's gonna be your G. G of X equals 2x minus 5.
So what does f of x equal?
F of X equals the absolute value of X.
There you go. You got it. That's all you're doing.
That's all they want us to do.
That's all they want you to do.
So your answer would be that whole thing?
They're going to ask you, what is your g of x? And you say what your g of x is. And they ask you what your f of x is. So it's just this part.
Okay.
They're asking you to define your two functions. That's what they're asking.
Okay. Gotcha.
So for 59, for example, what is your f? What is your g of x?
Your G of X will be 2x plus 1.
And what's your f of x?
G of X. The absolute value of X.
Okay, for 55, what's your g of x?
2x plus 1. Okay. For 55, your or the most inside value, right?
Uh-huh.
So it would be 2x plus 3.
And
That would be
what would your f of x be?
um, x parentheses to square root of 4.
X to the 4. It would literally just be x to the 4.
X to the 4.
You don't even have to put the parentheses in it. Because isn't this the same thing as saying this?
Yeah, it's the same thing. I was just talking.
Ah. All
It's a-
right. I have to go to bed, girl. I gotta do it. It's almost 11:30.
yeah, thank you. This was good. I learned a lot. I just, I realize there's a lot I don't know, so I need to do more reading. Um,
Uh, I'm gonna say this to you, and I tell all of my students this. Almost everything that you're going to do until you get to calculus is KISS, which means keep it simple, stupid. Don't overthink stuff. They're not trying to trick you. All of the stuff that you should be learning is pretty straightforward.
okay.
So when you're doing the domain and stuff, when I give you a process to do it, just follow the process. Don't try to overthink it. Don't try to make it more complicated. Don't even try to apply it to something else. Just learn the particular thing that you're learning.
Okay.
You'll save yourself a whole lot of headache. And I'm always going to give it to you the most simple way possible. I swear.
Yeah. Yeah. My teacher is great. It's like he's solving the problem for himself. Like, are you teaching us just solving doing your own calculations? It's just like,
As long as you send me a text sometime before 12 o'clock your time, I should be available to you. And let me know what time you want to meet. Don't wait till the last minute because I might be gone and I might not be at my house if you wait till the last minute.
okay. I will let you know as soon as I can.
Okay.
Thank you. Have a good night.
You're welcome. You have a good night too.
Bye-bye.
Also, I'll post this for you. I'm going to post it before I go to bed.
Okay. Thank you.
All right. You're welcome. Bye.